Good afternoon, I'm Mr. Ish. You're joining me for this video here. A good video here because we'll be doing this over two parts, two examples in each. And why am I bringing this topic up at this specific point? Because it's important and because this commonly shows up on subject exams, standardized subject exams. And without you being aware of this type of movement here with regards to graphs, it would be a disadvantage for you to proceed into those exams. Everything here is being looked at in a very generalized manner. We're focusing here on more letters and forms than actual movement in terms of numerical quantities. The question is this, and both of the questions will be the same except we'll be using different representations. Show the relevant equations and vertices for each step. When we are starting here, this is my first step. I've already provided you with what equation we're looking at. We're looking at a parabola here with a vertex at the origin, and then the next step is we see that it moves to this specific point over here. We're seeing what? We're seeing that the parabola has shifted to the right, and we know our basic equation form is x squared, and we'll be using the letters h and k. If the vertex over here is 0, 0, because we have to provide that, and the equation is already given, the starting equation is provided. Now we have to focus here, and we've seen that the parabola has shifted to the right. How can we demonstrate a shift to the right by h units? Well, we can do x minus h, because now we should remember a minus here indicates a rightward movement, and then we'll still have a square over here. So suddenly my equation has become f of x is equal to x minus h whole square to indicate we moved to the right by h units. The vertex over here will be h comma 0. Remember, we're in terms of y value, we're still at 0. When we come over here, we're seeing what? In terms of a change, we're seeing that the graph has reflected downwards across an x-axis. When we're looking at this, in terms of this now being the preceding equation, we have to modify it, and we modify it by bringing a minus right here. Minus x minus h whole square, and that represents the graph. What you see, the vertex over here will again still be h comma 0. Lastly, the graph undergoes a movement, and now you're seeing that the graph in terms of the vertex has shifted directly down. So we have to modify our equation and we have to modify our vertex. The new modified equation, when you look at it, will be put for you right here. It will be minus x minus h whole square, but it has shifted down by k units, minus k. The minus here indicating that it went down. So you're seeing all of these factors come into play. The h and k, the vertex, a minus representing the graph is pointing down. Here our vertex is going to be what? H comma minus k. So you can see how the movements and the vertices have changed, and this is something you should know how to do. Alright, question number 2, exactly the same format here. Show the relevant equations and the vertices for each step. We're always given a starting function here. The function is absolute value x. If you are good with graphs or competent with graphs, and I don't mean that in an insulting manner by any means, I'm saying if you are just good with remembering how graphs look, you know absolute value here has a vertex here at 0, 0, meaning the origin, and we're starting with that. Now we have to identify the shifts and put them in equation form. Here we're seeing that the exact same representation has shifted up by k units. We have got a vertical movement here by k. Remember, h represents your x value in terms of movement, k represents your y value in terms of movement. Here our function is going to be f of x is equal to absolute value of x, but it has moved up by k units plus k. What's our vertex going to be here? It'll be 0, k. There's no movement here in terms of the x-axis, but the movement is only in terms of the y-axis. And then we look over here, we see a movement now of that same function, but it has moved towards the left. And you know here the equation must be now f of x is equal to absolute value of x plus h. Here you have to remember the positive here indicates a leftward movement in terms of h. A minus would have indicated a right, but we're still plus k units up, right? Everything here looks good to me. Vertex over here must be what? It'll be minus h comma k. We're in the minus x quadrant in terms of the minus x values, but we're still positive in terms of the y or the k values. Everything looks good to me now. And now when I'm looking at this next conversion, I'm seeing that the graph moved down, but then it also reflected downward. So we have two factors coming into play over here. What we see over here is this f of x is equal to minus, reflecting a reflection downwards of that graph, x plus h. The movement has been coming down by k units. If this was right here, originally was a plus k, now we've moved down a certain units by minus k, we can just as well put a minus k over here and we will be good, because we're looking at the end result over here in terms of the graph. What I'm seeing here in terms of the function looks good, minus absolute value x plus h minus k, and the vertex based on this would be minus h comma minus k, indicating that a vertex here lands in the third quadrant, which it exactly is. And you can see how these two questions have played out, something very important. I'll post another video on the same topic with some more movements, and with that we should become slightly more competent in this subject. Thank you for watching. Have a nice day.